Dear students, welcome to today's class. In the yesterday's class, I explained about the actual fundamental definition of trigonometric functions. So once again, I am revising the definition. Let us take a two-dimensional system, x-axis, y-axis. Let us just take a circle of radius r. Let us say that the the center of the circle coincides with the origin. Okay, now, right. Now, OQ is the initial side and OP is the terminal side. Terminal side means which will rotate with respect to the center. Okay, now, right. As it rotates and either in clockwise direction or anti-clockwise direction, the angle theta will varies. Automatically, the coordinates of P, x, comma, y also will change. The coordinates of the point P also will change. That means if it is rotates means the x and y coordinates values are also will change. If it is P is in the first quadrant, both x and y are positive. If it is comes here, x is positive, x is 0, y is positive. If it comes in second quadrant, x is negative, y is positive. Like that, it will be rotated. Okay, now right. Now, our main topic is domains of trigonometric functions. What is the domain? Domain means theta value here. So these trigonometric ratios are defined as in this point x coordinate, y coordinate to r. That ratio is defined as sin theta. X coordinate to r. That ratio is defined as cos theta. And tan theta is nothing but y upon x. It is independent of radius. Cosecant theta, secant theta, cot theta, nothing but reciprocals. So out of three quantities, we will get 6 ratios. For that, these are the names given. Now I am going to explain about the domain. First, see here. Here in this case, invariable quantity. Invariable quantity means what? It does not change. What it does not change? R value does not change. Why? Because for a circle, R is a fixed one. R is fixed one. R is a positive quantity. So it is it cannot be 0. From 0 onwards, it is a positive. Okay, na? It cannot change. It does not change for a fixed circle. What will change as P moves on the circumference of the circle? The one and only one, the only two things that will change is what? X coordinate and y coordinate. So from this, your domain of depends. So whatever may be this value depends upon the domain of theta depends upon x value, y value. Okay, not r value. So here r is where, and also to define a fraction, so the denominator cannot be 0. It may be positive or may be negative. Cannot be 0. So here already r cannot be 0. Here also r cannot be 0. Therefore, the domain is here. The domain is set for sin theta. The domain is set of real numbers. If you take theta any value, so what is the definition is what? Y by r, y upon r. R cannot be 0. Y value may change. Yes, in the numerator it may be positive, may be negative. Okay. So what is the domain? Set of real numbers. For cos theta also, see the denominator r is always positive, already we defined. Therefore, the domain is set of real numbers. Now coming to tan theta. In tan theta, see the denominator x. X cannot be equal to 0. That is clear. First see that where x will be 0. Where x will be 0. First we will see that. Okay, now. Where x will be 0? X will be 0 when the point lies on the positive x-axis. This is 0, comma y, or negative y-axis. Sorry. X will be 0 when the point P lies on positive y-axis or negative y-axis. Then it will x will be 0. Now, if you define what is that? Y by 0. Y by 0 is not defined. Therefore, which angle you have to subtract? So theta cannot be equal to pi by 2. Okay, na? Right. If this terminal side comes here, what will be this angle? This angle is 270. 270 means how much? 3 pi by 2. Okay, again this terminal side, so up to here 90 not defined, 270 not defined. Again 360 plus 90. 360 means how much? 2 pi. 360 degrees means already 2 pi plus pi by 2, that is 5 pi by 2. For 5 pi by 2 also it is not defined. At the same time, if the terminal side rotates in an clockwise direction, that means what? If it rotates, it comes here, then it will be on the negative y axis, that means what? Minus pi by 2. If it comes again here, minus 3 pi by 2, minus 5 by 2, so on. From this, what can you say? For theta is equal to pi by 2, 3 pi by 2, 5 by 2, this tan theta is not defining. Tan theta is not defined. The one and only one reason is what? X will become 0. That's why what is the domain of this? Set of all real numbers, except where x is becomes 0. Where x will become 0 when x is equal to pi by 2, 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, so on. What are these 1, 3, 5? They are odd numbers. Minus 1, minus 5, minus 5, minus 1, minus 3, minus 5. What are they? Odd numbers. So, except odd multiples of pi by 2, tan theta is defined. Therefore, r minus 2n plus 1 pi by 2, where n is an integer. That means, if it is a pi by 2, it is not defining. If it is 3 pi by 2, it is not defining. Why? If it is pi by 2, the point px comma y lies on positive y axis. Therefore, here x will become 0, but here in the definition x is in the denominator. That's why. The same thing where x is in the denominator. See here, for secant also x is in the denominator. That's why for this also domain is same argument. Here x is in the denominator. Where x will be positive, now where x is 0, when x lies on positive y axis or negative y axis. Understand? So, tan theta, secant theta, domain is same. For tan theta, secant theta, domain is same. Why? Here the denominator is x, here also the denominator is x. So, same argument. Now, coming to cosecant theta, cot theta. So, here y. Where y will become 0. So, for example, if the point is lies on the positive x axis, that means x comma 0, otherwise negative x axis minus x comma 0. Understand? Now, what will be the angle here? That means if OP coincides with OQ, what will be the angle here? 0 degrees. If the terminal side comes here, what is that? Pi. If it completes one rotation, 2 pi. If completes again here, 3 pi. Again 4 pi, 5 pi, 6 pi. Okay. If this terminal side rotates in a clockwise direction, this is what? Minus pi, minus 2 pi. This is a minus pi, minus 2 pi, minus 3 pi. What is that? So, for that theta, for that angles 0, pi, 2 pi, 3 pi, so on, minus pi, minus 2 pi, minus 3 pi, so on, y will become 0. Y will become 0. For that, the trigonometric ratio is not defined. Okay, clear? It is not defined. Y will become 0. Here depends upon y. It will become 0. Therefore, the trigonometric ratio is not. That's why we have to define that function. We have to terminate. We have to eliminate those values. What are those values? 0, 1 pi, 2 pi, 3 pi, minus 2 pi. What are these? 0, 1, 2, 3, 4, so on. What? They are integers. In general, can I write down theta is equal to n pi, where n belongs to z? That means those angles, for those angles, this cosecant theta is not defined. Why it is not defined? Y value will become 0. That's why. So, what is your domain? So, your domain is a set of all real numbers except n pi, where n belongs to z. Here also n belongs to z. Okay, n belongs to z. Same concept, same logic applies here. Y value is in the denominator. For this also, set of real numbers except n pi, n belongs to z. So this is a very, very important concept. So as you are preparing for general up to 10th class, there is no need of any these domains, no need of that much importance. But as you come to the JEE mains and that point of view, you should know the domains of all trigonometric functions. Understand? So to define the trigonometric function, you see the denominator here r means r is always positive, a radius of the circle. It is always positive, and moreover it is a fixed for a fixed angle, fixed circle. So for this is domain is r, this is also domain, but for x, what the domain of y, what the x cannot be equal to 0. For which values x is 0? If the point lies on either positive y axis or negative y axis, so you have to eliminate all those pi by 2, 2 pi by 3 pi by 2, 5 pi by 2, minus pi by 2, minus 3 pi by 2, minus pi by 2. All for the all those except all those angles, this trigonometric ratio is defined. So this is same for tan theta, denominator is x. For secant theta is also denominator is x. That's why for tan theta, secant theta, domain is same. For cosecant theta, cot theta, domain is same. Okay, na? Right. I hope that you understand this how to find out domain of a trigonometric function. Now, how to find out the range of the function? To find the range of the function, the one and only one thing is drawing the graph. Drawing the graph only. So in the previous videos, I explained already how to draw the graph of all the 6 trigonometric functions. Okay, now, so here I will directly write that ranges of the trigonometric functions. Okay, now, so let us see the range of the trigonometric functions. Okay. I explained how to find out the domains of a trigonometric, all 6 trigonometric functions. Okay, now then how to find out the range of the trigonometric functions means through only graph. Okay, just see my previous videos, there I explained how to draw the tan, sin theta, cos theta, tan theta, cosecant, secant, cot. So just I am directly giving. So what is the range of sin theta means for all the values, whatever may be the value, angle you put, the maximum and the minimum values of sin theta is -1 and +1. Okay, so -1 is the minimum value, that +1 is the maximum value. For sin theta is also range is -1 to 1. So -1 to 1 including -1, 1. Okay, now right. So from -1 to 1, how many real numbers are there? Infinite number of real numbers are there. So whatever may be the angle you take in, except in the domain, so domain is set of real numbers. It takes the maximum value is 1 and the minimum value is -1. You see the graph. Okay. For cos theta also the domain is -1 to 1. -1 to 1. Okay, now right. For tan theta and cot theta, domain is set of real numbers. Set of real numbers. That means as theta increases, tan theta will all value is also increases. At cot theta, as theta increases, that cot of theta is also will increase. As theta decreases, tan theta is also decreases. If as theta decreases, cot theta, tan theta values are also decreases. Okay, now there is no bound. So maximum and minimum we cannot define. That's why the range of these tan theta and cot theta set of real numbers. For cosecant theta, secant theta here, for cosecant theta it takes -1 and 1 also, but these values lies out of that -1 +1. So that means open bracket minus infinity to -1 closed one union 1 to plus infinity. Okay, na? So for secant theta also same story, minus infinity to -1 union closed 1 to plus infinity. See here. So how to remember these values? For tan theta, cot theta, range is R, no doubt. For sin theta, cos theta, everybody will tell. The only thing generally students will forget the range of cosecant theta, secant theta. The only thing is remember this. So range means y value. So this is a 1 and it is -1. Okay na? Right. For sin theta, cos theta, this is the range in between this. This is sin theta, cos theta range, -1 to +1. For cosecant theta, secant theta, including 1 to plus infinity, here -1 to -infinity. Okay na? Here sin theta, you will take for sin theta, cosecant theta, you will take sin theta, cosecant theta, cos theta, you will take both one value and -1 value. For both it belongs to -1 and +1. For this is cosecant theta. This is cosecant theta, secant theta. Here also it is cosecant theta and secant theta. So this y value lies between, this is y range. Range is from -1 to 1 is sin theta, cos theta. From -1 to -infinity, 1 to top. The range is, those values are ranges of cosecant theta and secant theta. This can be verified, proved only through graph only. If you draw the graph of for various values of theta, you can easily identify all these things. Okay. I hope that you understand the concept of this domain and ranges. Okay. Now my question is here, as I had already told, sin theta range is -1 to 1, domain is set of real numbers. Okay. When I am saying -1 to 1, for which angles, see here from -1 to 1, from 0 to 1 positive values, from 0 to -1 negative values. For 0 is neither positive nor negative, of course. For which values, for which values of theta, sign will become positive and sign will become negative, that we are going to discuss. For same here also, same here tan theta we are saying set of real numbers. For what values of theta, tan theta is positive and tan theta is negative. What is the interval? In which interval of theta? That means from 0 to 90 or 90 to 180 or 180 to 270 or 270 again 360. For which intervals this tan theta is positive, tan theta is negative. Similarly, for remaining also we are going to see here. Okay na? So let us see that. So that is a very important thing, that is all silver teacups, that I am going to explain now. Okay na? Right. Concentrate on sin theta. I told sin theta domain is set of real numbers and the range is from -1 to 1. From -1 to 1, negative values are there, positive values are there. That negativity, positivity, everything depends upon the value of y, not on the value of r. Why? Because r is a radius of a circle, it is always a positive quantity and it is a fixed for a fixed angle. So that depends upon y value, not the r value. That means either it is a greater than 0 na, less than 0 na. Okay na? That we are going to see. Where y is positive, where y is negative. See here, y coordinate is positive in the first quadrant and second quadrant. Y is positive in the first quadrant, second quadrant, and third quadrant, fourth quadrant it is negative. That means in the first quadrant, okay, I will write down like this. I will write. So this is a Q1, this is a Q2. Like this, all afterwards I will analyze this Q3, third quadrant, Q1, Q2, Q3, right? Very nice. Okay, please listen carefully. In Q1, first quadrant, it is a positive. Second quadrant also positive. Third quadrant negative. Fourth quadrant also negative. It is negative. Fourth quadrant, it is negative. Why it is negative? Very simple reason. Very simple reason. If anybody asks you, array, sin theta is negative in third quadrant, fourth quadrant, why ra? If anybody asks you, very simple definition. Sir, the definition of sin theta is y by r, sir. R is always positive. This sin theta, either it is a positive or negative, everything depends on y value. The y coordinate is negative in the third quadrant and the fourth quadrant. That's why the sin theta will be negative in the third and fourth quadrant. Okay. So from this we can go. Right. Seventh. Cos theta negativity or positivity will depends upon x value, not on r value, right? What is x is positive? So x is positive in the first quadrant, no doubt. First quadrant, x is a positive. Next, which quadrant x is positive? Fourth quadrant, it is positive. It is positive, remaining negative. Second and third quadrant, it is negative, right? Tan theta. Okay, I will write down directly again. This. Okay, right. This. Now, tan theta, very, very important. Tan theta, y is also there, x is also there. Y is also there, x is also there. This is positive when both y and x are positive, and it is negative when, it is positive when it is both y positive, x positive, otherwise y negative, x negative. Y negative, x negative is also, it is positive. Why? Because minus will get cancelled, no? So, when it is positive, when it lies in first quadrant, that means y is positive, x is also positive. That means plus total plus. So, first quadrant it is positive. When it is positive, once again, when theta lies in third quadrant also, this is negative, this is negative. Y is negative, x is also negative. Negative it get cancelled. In third quadrant also, it is positive. Remaining cases, here minus plus minus, that is here in the second quadrant, x is negative, y is positive. Therefore, it is a negative. In fourth quadrant is also negative. That's all. Now, cosecant theta, secant theta, cot theta, just like we can easily say that it depends upon y value. It depends upon y value. So, y value means what? Y is positive, not r value. Y is positive. In which quadrants y is positive? Automatically first quadrant. And which quadrant y is positive? Second quadrant. So, here negative. Secant theta, r by x, it does, the negativity or positivity does not depends upon the value of r, it depends upon the value of x, right? X, where is it positive? Of course, it is the first quadrant, it is positive. Next, x positive in which quadrant? Fourth quadrant, it is positive, remaining negative. Cot theta, same, x and y, same logic applies as tan theta, y by x. Y and x both either should be positive or both should be negative, so that cot theta is positive. So, both are positive means here first quadrant, next third quadrant positive, remaining quadrants depending upon x value and y value, cot theta will be negative in the second quadrant and fourth quadrant. So, if you analyze what you see here, if you analyze what you see, in the first quadrant, all trigonometric ratios are positive. The first quadrant, all trigonometric ratios are positive. That's why first quadrant, all means all 6 ratios are positive. In second quadrant, what are positive? Sin theta, cosecant theta. See here, sin theta, cosecant theta only positive. That means yes, silver. That means here sin theta, cosecant theta are positive only. Okay, now, right. In third quadrant, tan theta, cot theta are positive. That's why tan t, to remember that only, tan theta, cot theta both are greater than 0. Next, fourth quadrant, cos theta and secant theta. So, cos theta is greater than 0, secant theta is greater than 0. That's why cups. This is all silver teacups. That means if your angle lies between 0 to 90, not 90, 0 to 90, all these trigonometric ratios are positive. 90 to 270, not 270, not 90. 90 to 270, only sin theta, cosecant theta are positive. If your angle, if you have taken angle between 180 to 270, only tan and cot are positive, and 270 to 360, the cot theta, cosecant theta, cos theta, secant theta are positive. And one more thing what have to remember is, and their quadrant angles are also we have to consider. What is meant by quadrant angles means, for example, Sin theta and cos theta. Sin theta is greater than, cos theta is greater than between which angles? 0 to, what is that here? Pi. Not 0, open bracket, not right down. Open bracket, 0 to pi. From 0 to pi, sin theta and cos theta are, sin theta, only sin theta, cosecant theta, right. Sin theta and cosecant theta both are positive from 0 to pi, open bracket. If it is 0, 0, 0 is neither positive nor negative. So, 2n pi, if you add 2n pi, 2n pi means what? If 2 pi, 4 pi, 6 pi means if it completes one revolution, it is a 2 pi. If it completes two revolutions, 2, 4 pi, 6 pi like that. So, that means this is a 2n pi plus 0. This is a 2n pi plus pi. So, that means 2n pi comma 2n plus 1 plus 2n plus 1 pi. For that angles are also sin theta cosecant. That means for that intervals add 2n pi. Add 2n pi. For that intervals also these work out. Okay. So, I hope that you understand this all silver tea cups. Okay na? So, next we are going to see the reciprocals. Reciprocal means already you know that reciprocals, that I will explain. Okay na? So, let us start the next concept. Now, I am going to explain what is a multiplicative inverse or simply reciprocals. Now, before going the trigonometric ratios, so multiplicative inverse, generally in set of real numbers, what is, I am explaining real numbers. Okay, what is in the set of real numbers, what is multiplicative inverse? If the product of two numbers a into b, if the product of two numbers is equal to 1, if the product, of course, non-zero real numbers, those cannot be equal to 0, a and b cannot be equal to 0. Non-zero numbers, if their product is equal to 1, then each one is called multiplicative inverse of other. Otherwise, we simply call it as a reciprocal. Okay na? So, a is the multiplicative inverse of b and b is the multiplicative inverse of a. Okay na? Right. The thing is here, out of 6 trigonometric ratios, just now I explained, there are all ratios, numbers, they are numbers. If what two numbers we can multiply so that we can get the product is 1 is, obviously everybody can say that the first one is sin theta times cosecant theta is equal to 1. The question is here, okay, if sin theta into cosecant theta is equal to 1, and that is up to 10th class knowledge. What about theta? What about theta? That we have to see here. I explained about the domain of sin theta and domain of cosecant theta separately. But it is a trigonometric equation. When you are taking like this, you have to consider the domain of intersection of the domains of sin theta and cosecant theta. Understand? What is the domain of sin theta? Set of real numbers. What is the domain of sin theta? Set of real numbers. Intersection. What is the domain of cosecant theta? Cosecant theta domain is what? Set of all real numbers except n pi, where n belongs to z. That means this intersection part you have to take. Always. Sin theta domain and cosecant theta domain, intersection part. What is the intersection part? R intersection, this means this only will come. Small set only will come. This is a small set, this is a big set, this will come. That means theta does not belongs to n pi, where n belongs to z. Understand this? So, whenever you write that, write specifically. Don't write down simply sin theta into cosecant theta is equal to 1. Always remember this also. Theta is not equal to n pi. Why? The domain of sin theta is set of real numbers and the domain of cosecant theta is set of real numbers except n pi. 1 pi, 2 pi, 3 pi, 4 pi. Okay. That means their intersection part is obviously small set. Small set means what? In short, we can write down this, or in short, theta does not belongs to n pi. Okay na? Right. So, second one is cos theta into secant theta is equal to 1. Right, cos theta is equal to, already I explained, and secant theta I explained. If you multiply those two ratios, you will get 1. So these two are real numbers, already explained. Cos theta and secant theta, they are real numbers. Okay, now, right. So what is this condition holds when it is holds. Okay, now, right. When it is holds, cos theta domain is set of real numbers intersection. Secant theta domain is R minus of 2n plus 1 pi by 2, n belongs to Z. So what is their intersection part? Obviously small side, that means this side. Otherwise you can write down theta not equal to 2n plus 1 pi by 2. That means where n belongs to Z. This inequality holds when, sorry, this equality holds when theta is not equal to 2n plus 1 pi by 2. Okay, now, right. Next one. Third one. Tan theta into cot theta is equal to 1. Tan theta into cot theta. Right. So tan theta into cot theta. So this, what is that? What is the domain of tan theta? Domain of tan theta is set of real numbers minus secant theta, tan theta same. 2n plus 1 pi by 2 intersection cot theta domain is n pi, set of real numbers except n pi, n belongs to Z. Okay, what is their intersection part? What is their here? You are not supposed to take odd multiples of pi by 2. Here you should not take the integral part of pi. Therefore, combining together, you have to write down theta is not equal to 2n plus 1 pi by 2 and theta is not equal to n pi, where n belongs to Z. So dear students, why I am telling you, as you are preparing for JEE mains and JEE examinations and higher examinations, everything you have to learn precisely you have to write, clearly how to write down. Whatever may be written, sin theta into cosecant theta is called. What here? Theta angle. What is that angle? That theta should not be equal to n pi. Cos theta into secant theta is equal to 1. When this identity, this also call it as a trigonometric identity, we can order. So accept the values of this 2n plus 1 pi by 2, odd multiples of pi by 2. This cos theta and secant theta holds good. Okay, now, so you cannot put the values as you like. You cannot put the values as you like. Why? Because for a cos 90 0, but secant 90 1. Cos 90 0, 0 into 1, 0 you are getting. Now, if anybody asks you, cos theta and secant theta, how much ra babu? 1 sir. Okay sir, very good. If cos theta is 90 degrees, cos 90 is how much? 0. Secant 90, 1, 0 into 1, 0 gara babu. How can it be say? They will ask. Then you have to say, sir, cos theta into secant theta is equal to 1, but except theta is not equal to odd multiples of pi by 2, sir. So you should not take pi by 2, 3 pi by 2, 5 by 2, coming to in the negative direction, minus pi by 2, minus pi by 2, that values you should not take, sir. Then only this equality holds. That's why it is called, except these values, for all values it equals. That's why it is called identity. Okay, for the same logic applies for tan theta and cot theta also. Okay, I hope that you understand this concept. So let us go for next concept. A very important concept, that is trigonometric identities. Okay, so everybody know that. So first trigonometric identity is sin square theta plus cos square theta is equal to 1. As I already told, what is theta? So this is a trigonometric identities. You have to take the value of theta which satisfies both sin theta and cos theta. Okay, now that means you have to take the intersection of the domains of sin theta and cos theta. So what is the domain of sin theta? Set of real numbers. What is the domain of cos theta? Set of real numbers. Therefore, for all, theta belongs to real numbers. Theta value, whatever may be that you put here, theta value 30 degrees, 40 degrees, 200, 500, whatever may be that, sin square theta plus cos square theta value is 1. Understand? Right. Sir, what is the proofs are? Very easy. So as I already told, what is the value of sin theta? Sin theta value is y by r whole square. What is the cos theta value? X by r whole square. So this is a y square plus x square upon r square. So y square plus x square. If you observe these lengths, x square plus y square is equal to r square according to the Pythagoras theorem. R square by r square. R square will get cancelled. That proof is very clear. That everybody knows. The thing is, theta belongs to r. That is the first thing. Second trigonometric identity is secant square theta minus tan square theta is equal to 1. Right? Secant square theta minus tan square theta is equal to what is theta? So I already told the domains of tan theta and secant theta both are same. Tan theta, secant theta. Why? Because for tan theta also denominator x, for secant theta also denominator x. Tan theta denominator is x, for secant theta denominator is x. That's why for tan theta, secant theta domain is same. Therefore, their intersection is also same value you will get. Therefore, for all theta does not belongs to 2n plus 1 pi by 2. This also you have to remember. Okay now. So if anybody asks you, Arey Babu, what is secant square theta minus tan square theta? 1 sir. Sir, if it is theta is equal to 90 degrees, what happens, Babu? So tan 90 is not defined, no, then how can it will be here? Then you have to say immediately, sir, secant square theta minus tan square theta is equal to 1, where theta does not belongs to 2n plus 1 pi by 2, sir. Why? What is that? I explained already. So domain of secant theta and domain of tan theta both are same. You have to take their intersection part. Intersection obviously both will be same, except odd multiples of pi by 2, except odd multiples of pi by 2. For all values, secant square theta minus tan square theta is equal to 1. That's why it is called identity. Everybody say identity means for all values it satisfies. Not like that. Except the restricted values. Except that restricted values it satisfies. Okay. Here what are the restricted value? 2n plus 1 pi by 2, where n is belongs to z. And from this also we will get two results. What are those results? Secant theta plus tan theta into secant theta minus tan theta is equal to 1. So therefore secant theta plus tan theta is equal to 1 by. For that also this condition is satisfied. That means secant theta plus tan theta is equal to 1 upon secant theta minus tan theta. For this also the condition satisfies. Same condition apply. And last but not the least, and the third trigonometric identity is cosecant square theta minus cot theta is equal to 1. For which values this identity will satisfy? It means what is the domain of cot theta, what is the domain of cosecant theta? For cot theta, cosecant theta, same domain. What is the domain? Set of real numbers except n pi, where n belongs to z. So therefore we can say for all theta does not belongs to n pi, where belongs to n. That means you should not take n pi. That means pi, 2 pi, 3 pi, 4 pi, this side negative direction, minus pi, minus 2 pi, minus 3, those values you should not take. So these are the proofs. You know that proofs already. Secant theta proof is, everybody knows secant theta means how much? Secant theta means r by x whole square. Tan theta means y by x whole square. That is r square minus y square by x square. R square minus y square, r square minus y square is equal to x square by x square. X square gets cancelled 1. Okay now. So what is the cosecant square theta minus cosecant theta definition? Cosecant theta definition is r by y square minus cot theta definition x by y whole square. That is r square minus x square by y square. R square minus x square means y square by y square. Y square will get cancelled. The value is 1. Understand this? So these are the proofs. My intention is these values, all these values everybody knows. Only these values, only the meritorious students have to remember. Those who are preparing seriously for JEE mains examination, these values you have to remember. Then only the concept will be completed. Okay now? So dear students, I hope that you enjoyed today's class with some more topics and problems. In tomorrow's class, I will present before you. Until then, all the best.